inequality requires us to start with reverse PEMDAS. So PEMDAS is your parentheses, exponents, multiplication, division, addition, and subtraction. So when we look at these, we want to make it x is greater than or less than or equal to some number. And currently we have it with several other numbers in there. So we're going to work these out in reverse PEMDAS form where we're going to add and subtract away first, and then we're going to multiply and divide away. So for the first one, we're going to add and subtract. So we'll add 3 to both sides. So we'll end up with a 2x is less than, and that's going to be 4 plus 3, which is 7. So 7 is greater than 2x. At that point, we'll divide both sides by 2 because we did our addition subtraction. So now we must do our multiplication division. Divide both sides by 2. Cancels out. You have x is less than 7 over 2 as your first part. Now we'll do the second part of this one. And I'm going to get a different color out just so it stands out. So this one's going to be x, and this one's a little bit simpler. We're just going to subtract 3 from both sides. Actually, how do I do that? I want to do it this way. Minus 3, minus 3. So these two will cancel out, and then we end up with x is greater than or equal to 5 minus 3, which gives us 2. So x is greater than or equal to 2, right? So we already have two parts of this equation. And we're looking at the fact that it is an and. So on a line chart, I'm going to draw this out for us real quick. Actually, can I make a line? Yes, I can make a line. Come on. Oh. Okay. I wasn't expecting that to be red, but all right. Made a line there. Let's say this is 0, which makes this 2, and we have a negative, I bet, 7 over 2. No, they are not being helpful. Why are you not letting me erase this? Okay. So we're going to have a 2, and then we have a 7 over 2. And we know for the first line down here, the blue one, that x is less than 7 over 2, right? Which means everything from negative infinity all the way up to 7 over 2. What? Come on. There we go. Exists for that blue line, right? And then we're going to go for the red one that we made. X is greater than or equal to 2, right? So that means with that one filled in and onwards to infinity, it exists, right? Now we're looking at an AND statement. An AND statement requires both lines to be there at the same time. So both lines exist from green colors. From 2 all the way to 7 and 2/2, but this one here, you got to remember, was empty. So if we were to write that in set builder notation, we'd say that it has a bracket at 2, and it went to 7 over 2 parenthesis, right? That's how we would write this equation for this AND. The graph form is basically drawing it, which we already did draw it out, and then we sketched the two and said that this is the actual true graph of it, right? Okay. Anybody got questions on that one right now real quick? We good? All right. Question 2. Yep. So in set builder notation, Oops, I did make a mistake there. This is interval notation. Set builder notation is where we put saying that for all real numbers that are x, the answers go from 2 less than or equal to x, which is less than 7 over 2, and then we close with the bracket. So that's what the end answer would look like right there. That's interval notation. That's the set builder notation that they're looking for. Because we're stating for the variable x, we want between 2 and 7. Basically, we put them together because it was an and statement. And then from there, we put the x, we put the x on the outside to say that our variable is x and that we're looking for that variable x, and it can exist between these 2 points. And then we told it how it touches those 2 points. This one, it will actually touch it. That one, it won't. All right? That's a good speed for a question, right? We should be done with this in no time. Sorry for all the people on the microphone. Okay, so solve the compound inequality and give the solution interval notation. So for this compound inequality, it's the same as the one before, but they shorthanded it into one equation with 3 parts. So if I said I'm going to multiply both sides by 3 to get rid of the dividing of 3, what I'm actually doing here is I'm multiplying everybody by 3. So I get to multiply this side by 3, I get to multiply the center part by 3, and this guy over here by 3. So let's start with going negative 8 times 3 is less than 2 minus, this is 6x, right? Yeah, 6x over 3 times 3 is less than or equal to 3 times 3. Of course, in the center, this will cancel out the 3 and the 3, right? Then we'll go 8 times 3 is 24, so negative 24 is less than 2 minus 6x is less than or equal to 9. All right, with me so far? So at this point, now we're going to subtract 2 from both sides. Give me one more. I got to shut down the blinds because they're interfering with their things. The light's already interfering with my stuff. Hi. No, it's just I can't see. I'm running the tutoring for the 33. There we go. It's so colorful now, right? Dark. Okay, so in this part, since we have a positive 2 here and then we have the 6x, we're still working with the reverse PEMDAS. So we're going to subtract 2 from all sides. So if we subtract 2 from all sides, we'll get the negative 22 is less than negative 6x is less than or equal to 7. Now here comes the fun part. We have a negative number that we're about to divide by, because we're going to have to divide everybody by negative 6. When we do this, we're going to have to flip all the signs directions. So we're going to make sure to do that right now real quick before anything else. I'm going to flip every sign direction before I write the rest of this.
If you divide by a negative number, but the signs don't change,
They always change when you divide by a negative number. Whenever we divide by a negative number or multiply by a negative number during the movement of an inequality, we will change our signs. It's okay. It's okay. So doing this, divide both sides by 6. Did I do the math wrong? Before I split into... No, okay. I'm still fine. Wait. No. Wait. Yeah. No, there's something here wrong with the... I'm having the same equational problem that... Okay, so this is actually a mistake. We're going to remark that into it being a 6, because that was actually... Come here, you. Okay, well, either way, this is now a 6, because that was a mistake made. So we have 26 over 6, and we have... Do I math that horribly?
26 over 6.
And that side over there is a 7 over 11, right?
7 over 6.
7 over 6. Okay, so it's still 7 over 6. So we've got the 7 divided by negative 6 over here. We've got an x in the center. And we've got the negative 26 over 6. Which if we do a simplification on that, we'll get it down to 13 over 3. Does it still have a negative sign on it? No, it doesn't. Because this was negative and the 6 was negative, therefore they both canceled out and they made it positive. Okay? That's also, they flipped sides. So this is the positive number and it's greater than x, and then x is greater than a negative number, so it makes sense. So we're just going to quickly rewrite that so that it looks from from least to greatest. Go away now. Go away now. Go away now. Thank you. So we'll have the negative 7 over 6 is less than or equal to x is less than 13 over 3.
We're just rewriting them.
I just rewrote it around so it looks better that way. The next step we're going to do is turn it into interval notation, which usually is you trying to read it from left to right when you do interval notation so that you can keep it in line. So if we're doing that, we'd start by saying that this is an and statement, and both of these are clearly going in opposite directions. So you'll have another scenario where you have one line that goes to a stop point, and then another line that picks up before that stop point. So that means you'll have this section in between that we're going to be doing an interval about. And that interval will be between these 2 points. So we're going to read it as this sign here. I don't know if anyone knows owls and robots and how that works. But simple little side fact is if it has open circles, it uses greater than or less than signs, and it has parentheses, and that's an owl. And then if it has, let me give it a different color just for the fun of it. If it has closed dots for eyes, has all these extra mechanics, and it's greater than, less than, equal to signs, and it uses brackets, you have a robot. Robots are precise at getting to points. Owls are not. So if you cover up the half of one of these, you'll realize that you have a closed dot equals greater than or less than sign equals a bracket, and your owl, open dot, parentheses, it'll help you keep your interval notations with your signs with your graph lines. So you'll know which ones are for which items. But now going back to this, we're going to say, all right, our first one is negative 7 over 6 is less than or equal to x. So that means it's going to equal it. It's a robot, therefore it gets a bracket. So we're going to put a bracket on the outside and go negative 7 over 6 parenthesis, and then it's going to be existing all the way up to 13 over 3, right? And then we go, how does it touch 13 over 3? Well, it uses a less than symbol. So a less than symbol doesn't equal, therefore it is part owl, and it doesn't exactly touch it. Therefore, we will say, with green numbers, that 13 over 3 with a parenthesis would be the answer for that part, right? We have made our interval notation. Yep.
When did we go from 7 over negative 6 to negative 7
The negative sign sits on the outside of the fraction, basically. It doesn't matter because it's almost like saying if I, okay, so, and this is a side note for anyone that's watching this later on. If I have a negative 3 over 2, and I have a 3 over negative 2, and we did this in a chart form, and I said, okay, I'm going to go 1, 2 positively run over, right? And then I went 1, 2, 3 down negative. That's this, right? I just proved that that's what that was I did, right? I counted 2 over, and then I went 3 down, right? So over on this one, I'm going to go 3 backwards, and then I'm going to go, or sorry, 2 backwards, because negative 2, and then I'm going to go 3 upwards. It's the same line either way. Like, either way, no matter where you put it, it'll be the same. It's just math-wise, you're always going to see the negative sign put on the top of the fraction in a test or homework or something like that. They don't put it on the bottom because the calculator reads it in front of the whole equation. But either way, it'll be the same thing. Like, it does not change how it works. It's just a formality thing. But that's the cool thing about lines and how their negativeness works with each other. That's also why the whole rise over run works if you do it the wrong way. If you like mix the points up, you'll just end up with a negative version of your slope, which is still the same slope. But anyways, up to here, this is what our interval notation would look for this one. And if you drew the graph, you would see those two lines, and they would intersect, and they would look like that little box in the center. All right? Let's look at question 3. Going a lot. Time's going by a bit faster than I thought it would. All right, so solve the absolute value equation by using properties of absolute values. Okay, so properties of absolute values, we know that when the absolute value is there, we split it into 2 different equations, and we work them down from there. However, this one has stuff that is on the same side as the absolute value, but it's not inside of it. So the goal is to move that stuff to the other side before you split it into 2. Makes it a lot easier for you later on. So we're going to do that real quick, use our reverse PEMDAS. First thing we've got is a 3 sitting out there by himself, so we're going to subtract 3 from both sides, and that's going to give us a negative 4 absolute 2x plus 1 absolute equals negative 7 minus 3 goes to a negative 10 equals, and at that point, plus 1? Why? Oh, because I wasn't reading. Thank you. I missed that one. Thank you. So now at this point, the next thing we're going to do is we're going to divide both sides by negative 4 so that we can get away from the absolute value sign. And we'll end up with a 2x minus 1 inside of an absolute value equals negative 10 divided by 4. Right? I can. I'm just making sure that's the way they want to go here. Hold on. Let me just pause this real quick. Oh. All right. So at this point, we're going to treat that as it is equal to 2.5. And we're going to have both a positive and negative form of this. So I'm going to use my colors. I have the negative form in blue, which will be negative 2x minus 1 equals 2.5. And then, come on, please. Thank you. Positive 2x minus 1 equals 2.5. 5. And we went with decimals because decimals are easier to calculate with. Start with the positive one. So if we're working that down, we're going to positive doesn't matter. It doesn't change any of the signs. But what we're looking at here is we can move the 1 away because we're doing reverse PEMDAS first. So we're going to add a 1 to both sides of the equation, which will end up canceling these two ones out. We'll get 2x equals 3.5 because we added the 1 to the 2.5. At that point, we'll divide both sides by 2. And you'll end up with the math saying that that's going to end up being x equals 7 over 4. You could have done that in fractions as well, but you would have had to fractionize the 1 and then bring it back in. We're going to do basically the same thing with the negative form now, where we're going to, but first of all we have to distribute the negative sign, so we're going to make this negative 2x plus 1 equals 2.5, so that means we have to subtract 1 from both sides of the equation now because it's a positive 1. Those cancel out on this side. Negative 2x equals 1.5, and then you divide both sides by negative 2, and you get x equals negative 3 over 4. So if those are going to be the 2 points at which it's going to equal this. So x could either equal 7 over 4 or x can equal negative 3/4. Both of these answers will make this a valid statement. We good? All right, cool. Okay. Oh, graphs. Graphs are cool, right? We all like graphs? Yeah. So graph the linear equation by finding and plotting its intercepts. So when finding and plotting intercepts, that means that we're plugging the other item into being 0 because these two large bars in the center of the map are the axis bars. Axis bars is what I'm looking for the word. Where this entire one along this line here, y will always equal 0. So wherever x crosses that line would be the x-intercept for it. Same for the y-intercept is wherever it crosses the x-axis here, the y-axis here. Okay? So what we'd be doing for this one is say I want to find the y-intercept first. That means that x must equal 0. So in this equation, minus 3x plus y equals 9. I'll insert a 0 in for x, and then that ends up negative 3 times 0 cancels out, and then you just have a y equals 9. And you already know where one of your points is going to be. You could just put it in coordinate pair form where you'd say x is 0, parenthesis, y is 9. And that's because whenever we're dealing with graphs and we do parenthesis pairs, it's no longer the interval notation. It just goes, this is the variable x and this is the variable y. Okay? Got it? So that means we know that this equals y-intercept. Now we're looking for the x-intercept, which will be the simple change that y equals 0. So we'll then plug it into that equation from before, and we'll have negative 3x plus y, which is 0, equals 9. From here, it's not as straightforward as the other one, but still we get rid of the 0. We then say, well, we need to divide both sides by negative 3. And then from there, we get x equals negative 3 because 9 divided by negative 3 is negative 3. And then we'll take this number plug it in with the fact that y equals 0, and we'll know that our x-intercept is -3, 0. And then I think they want me to graph it on here, so we got to stick it on there real quick. So that one says -3, 0. So we'll go 1, 2, 3, 4, 5. Okay, so they're going by sets of 2s on the grids. So we're going to go 1, 2, 3. So 3 at 0. That's a good point, right? And then our other one I did in red, right? So the other one says at x equals 0, y equals 9, right? So we'll just go 1, 2, 3, 4, 5, 6, 7, 8, 9. No, 9's there. 9's there. So if that's 9, and that was 3, then we're just going to go over here, turn my lines black, take a line here, and just kind of sort of, there we go. The accordion looks a little bit better this way, and that's how I draw my line. Just by getting those 2 points, by plugging 0 into the other option of x, or y or x. Okay? So we graph the linear equation just by finding the intercepts alone. So you can do that with any number. Like if I said x equals 5, you could then do the math to figure out what y equaled at x, and then just put a dot right there at that spot, put a different dot, and draw the lines between the two. Be the same. Find the slope and y-intercept for the following line. So first of all, we're going to work this into our slope form, which I'm sure we've all heard it now. Y equals mx plus b, where m equals slope and b equals intercept. Well, b equals the y-intercept, not the x-intercept, the y-intercept. So this formula over here is not in that form. So I'm going to have to change it around a bit to make it in that form. I could move the y value over this side, and I could move the x value over to this side, but instead, I'm just going to move the number away, and I'm now going to make this mess go away. Oh, please let me in. Oh, okay. Been erased. We're going to say we move the 7 across the other side, and we're going to add 7 to both sides in order to do that. This side will cancel out, and we'll have x plus 7 equals 5y. And we're just going to flip their positions now, because if we just flip them, both of them can stay the same positive, right? You with me on this? Okay, so like, 5y equals x plus 7. Like,
I thought you meant
yeah. No. Like, all we're doing is flipping the positions, because since the other side moved as well, we didn't make anybody negative. Because we would have made the entire x plus 7 negative, and we would have made 5y negative, and then because both of them were negative, we just made them positive again. That's the explanation behind it, but I just wanted to make it look better so it's in the right form for y equals mx plus b, because the next cool thing I'm going to do is I'm going to divide both sides by 5. And that's going to cancel out our 5s there, and we're going to have y equals 1/5 x plus 7/5. That is our y equals mx plus b slope form. We now have to identify which part is slope and which part is the y-intercept. Which, as we said before, that m equal slope equal rise over run equal y2 minus y1 over x2 minus x1. Sadly, M has an identity crisis. He doesn't know what he wants to be called at any given point in time. He has about 4 different names. These are all of them. Recognize him no matter what name he's using. He's still the same thing. Rise over run seems scary. Y2 minus y1 over x2 minus x1 can seem very scary when they ask you to find that, but they're just asking for the slope. They're asking for M. Don't let him fool you with all of his names. He's very crafty. As for the other fact, the other one that we have there, variable b equals the y-intercept. And that's just because if x equaled 0, m would not exist, and just y ends up equaling b. So that's why it's the y-intercept. So at this point, we're just going to say this part here is our b value. So that means our y-intercept will end up being 0, 7 over 5, or b equals 7 over 5, depending on how your teacher wants it. Because they'll either want variable equals number, or they'll want the actual coordinate point of that intercept. Usually it'll be b. But the other one, slope form, slope form is hiding right here in front of x. It also includes whatever sign they have. If it's a negative sign on the front of that, it goes with the m, not with the x. So the slope for this one will just be 1/5. So we know the slope's 1/5, and our intercept is 7/5. That's how we make this one. Write the equation of the line to the given points, slope-intercept form. So this is where we go back and remember that slope has several different names. One of them is y2 minus y1 over x2 minus x1. And it looks scary, but all you got to remember is that your 1s and your 2s have to be from the same set. You don't have to worry about which set you pick to be 1 and 2 because of the negative principle I taught you earlier. You just have to make sure that you keep that pair in the right set. So we're going to say that the first set is going to be our 1, and the second set is going to be our 2 value, right? So y2 minus y1. So that means that we're going to have, since y value is 9, right? It's going to end up minusing the -8, but I'm also going to write the 4 down here so you can see this better. I'm going to draw this all pretty like, just so I don't get anybody confused out there. Minus, minus, and then as for the red ones, you have the -8, -3. Okay, maybe this wasn't my best movement, but okay, so. And that's where you can see now that the 9 comes from the second pair, and that's the y2, minus the y1, including its sign, sitting there. Then you'll have the x2, which is 4, minus the x1, which is a -3. Now, the cool thing about these is it's negative, negative. We'll just turn them into positives, and we'll just add them across. So 9 plus 8 would be 17. And then you have 3 plus 4, which is 7. So you have 17 over 7. And that should be your slope. Checking up on myself here. Okay. Given through. Okay. But we're looking for like the full equation. So we've got halfway through the steps here. We do know that this equals m, and that's the first part. However, now you have to remember that we have the equation y equals mx plus b, and we know m is the 17 over 7, right? We have x, we don't know what b is, and we know that there's a y over here. Y and X are usually just considered constants, constant variables. They're always going to be there. But here's the cool thing. Because we have 2 points, we have actual numbers we can plug into them. So let's say I took some numbers like a 4 and a 9, and I stuck them into the equation in those 2 spots. So now I have a 9 equals 17 over 7 times 4 plus b. Now I have one variable. I have several numbers. I'm now going to do the math between these numbers to tell me what that one variable equals. Multiply 17 times 4. Skip that. Okay, so at this point we'll imagine this is over a 1. 17 times 4. I have people with calculators with me.
60 over 7.
This piece here.
Yeah, 68 over 7.
68 over 7. Cool. Does it simplify down to anything? Okay, cool. So at that point, we need to subtract it from both sides so that our b ends up being alone because it's added to the b and it equals the 9 right now. So that means 9 minus 68 over 7 would be, and then if you're using graphing calculators, you want to hit the second, or no, you want to hit the math button and you want to hit fraction and hit it one more time. 5 over 7. So I have 5 over 7 positive?
Yeah, positive.
Okay. Equals b.
When did it become a negative 68?
It's still negative here. Yeah. So this is positive at this point, but I have to subtract it from both sides. I missed a step. That never happened. Okay, so at this point it was 68 over 7 plus b equal 9. And then we're going to subtract 68 over 7 and subtract 68 over 7 from both sides. This side cancels out at that point. And then we end up with 9 minus 68 over 7 equals b, or negative 5 over 7 equals b. So now we know our b value. And if you recall all the way up here, somewhere, yep, there's our n value. So at this point, we'll go y equals x. And then we'll go, all right, so our n value is 17 over 7. And then because b is a negative number, has a negative number in its fractions, we're not going to say plus 7 over 5. We're going to say minus 5 over 7. I had a moment of dyslexia there earlier. There we go. And this is our slope formula at the end. Basically takes all the knowledge about how these things work together in order to get an answer with them. But the cool thing is you get to know all of this just by having 2 points. That's all it takes. Or points and a direction. Are we good? We know where we're still going on this? All right, number 7. So write an equation of a line through as parallel to 5x plus 6y over equals 60. So first we're going to have to turn the equation into y equals mx plus b form to figure out its slope. And then we're going to have to go plug it in with those points to tell us what the b value is going to be. So let's first of all work with this by subtracting 5x from both sides. You get 6y equals negative 5x plus 60. And then you're going to divide both of these by 6. And at this point, I say you're done. You don't have to fully solve it. You don't have to solve the 60 portion. You don't have to solve all the rest of it. Because what you've already done is you've figured out that that right there is negative 5 over 6. And that's just the part you need. You don't need to know what happens to the b portion of this one because it's just parallel that line. All right? So we're just going to take that. We're going to run off with it and go negative 5 over 6 equals our m value. And then we'll rewrite the equation, and we'll have this as y and this as x. So negative 3 equals, because that'll be y equals m, which is negative 5 over 6 x. Oh, sorry, x goes here. This one's going to be the number. Hey, you. No. Come on. That one's a 4, right? Yeah, 4. So at this point, we're going to solve the numbers down. We're multiplying 4 over 1 times a negative 5 over 6. Calculators. Negative 10 over 3.
Is that right?
I like negative 10 over 3, yeah. I just had to understand what I'm looking through here. Negative 10 over 3 plus b equals negative 3, which now means we're going to add 10 over 3 to both sides. Okay. Where'd my thing go? You better still have it. No. No. Yeah, as soon as he started touching his calculator, it got bad at him. So you need to take that from him and check it. He might have some hacking material on there. Oh, he hit the record button on me. Well, IT fixed this, so that's good. So at this point, we're going to end up subtracting it from both. Come on, I'm a few steps behind here. I lost a few steps here. I need recovery. Where was I? So I'm adding to both sides, right?
Yeah. Yeah, because the answer was negative 10 over 3.
Right. So this was plus b equals negative 3, and then we're going to add 10 over 3 to both sides so that these cancel out, and then b equals negative 3 plus 10 over 3, which is
Yes. Which is 1.
okay, so I got to beat you that time because I just happen to know my math that well. So we have the 1/3 equals b, and we know that the m equals the negative 5 over 6. So we're going to then go take these items and we're going to stick them together in the same equation. Go y equals blank x plus, and we'll go 1/3 over here, and then we're going to put the negative 5 over 6 there. We have an equation using a parallel line and a point. Wasn't so hard, right?
How
What?
is that parallel line? Oh, never mind.
Because both the line that we solved for earlier and this line here both have a slope of -5/6. 5x with the 6 on the other side, which is why we don't immediately jump and take the number right next to x. We have to remember to put it in y equals mx plus b SOAP form before we take that, because any other instance, that's not m. M is incomplete at that point. It's good to know you thought about that, though. All right, next part. Determine whether or not parallel, perpendicular, or neither. So we're going to take both these equations. We're going to turn them y equals mx plus b. We're then going to look at both of their slopes, and either their slopes will be the same, their slopes will be inverted and negative of each other, which makes them perpendicular, or they're going to be something else, and at that point, they're nothing important to each other. So it's probably going to be one of the first two, if we're doing it. So we're doing our reverse PEMDAS. For the first one, we're going to subtract 4x from both sides. We'll have a negative 9x equal, or no, negative 9y equals a negative 4x plus 7. And then we'll divide both sides by negative 9. And then we'll know y equals 4 over 9x plus 7 over 9. No, minus. My bad. Because the 9 on the bottom is negative, and the 7 on top is positive, so the negative sign shines through. And that's more kind of why we put the negative on the top part. Because, like, presentationally, it's going to be in front of. So it just gets glued onto the 7, usually. Okay? That's how that gets there. So at this point, we know that this one's slope is 4 over 9. Now you got to figure out if the other one is anything close to or different from. So this one's going to be this over here. So the first thing we're going to do is subtract 27x from both sides. So we'll get 12y equals negative 27x plus 14. All right? And then from there, we're going to divide both sides by 12. So 27 is 27 over 12x plus 14 over 12. This will be something, but we're not worried about this part, right? But we're not worried about that part because it's the b value, it's not the slope. However, what we do know is this one here will simplify to a negative 9 over 4, which, if we look at that, it is our reciprocal that is negative to our first one, which makes this perpendicular to our first item. And we can kind of prove that. You guys want like a graph chart on how to prove that? We're going to go a little bit full. So if we started a point here, come on, there we go. And the first one says I'm going to, and remember these are rise over run, so I'm going to run 4 out. So 1, 2, 3, 4 out, and then I'm going to, because it's negative, I'm going to fall 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that'll be my point there. And that would be my line for, where's my mouse over there? Why is there a mouse down there? No. Weird magics. All right, and then we're going to go flip back over to our blue one, and we're going to say, okay, so starting at the same point, if I went 9 out, so 1, 2, 3, 4, 5, 6, 7, 8, 9 out, and then I went 4 up, 1, 2, 3, 4. you'll notice that these two here are actually a 90-degree angle from each other. So that's how you'll know that it's a reciprocal. It's a really cool drawing thing that you can do with your graphs. And that's how you'd prove your 90 degrees, which kind of shows you that they're exactly perpendicular to each other. But then in that case, we know that these are perpendicular. They're not parallel because they do touch at a point. And they do have a 90 degree between them because they're reciprocals. Question number 9. Determine whether or not a relation is a function. So how do we know whether or not a relation is a function?
If they repeat, it is not a function.
Okay, so 2 different ways that we can do this. We can say the vertical line test if we had them graphed, or we could say that if we notice that 2 of the x values are the same. If 2 of the x values are the same, for example, -2 and -2, we know that this is not a function. A function requires each x to be unique. This is kind of a weird one because I'm just having to explain like the words and the rules of it. But the terminology of it would be if I was like drawing a line here and I did a vertical line test, so I take this line and I run it all the way across to the other side of that line, it wouldn't touch the same place twice. But if I made this line here, at this point, it stops being a function because I'm touching both here and here at the same time. I'm doing it all the way through to this point. For that up there, basically what we're seeing, how do I put this? So, at 0, it has a +1. So if this was our line slope and this was our form of 0, yeah, that'll work. Okay, so 1, 2, 3, 4 out, it's at 0. So that's a point that exists on this relationship. At point 0, it equals a +1. So that also exists on this. Then you have at -2, you have it both existing at a +1 and at a +4 value. So the line could be drawn like this, and then somewhere over here it does that. At this one instance in the line, it becomes not a function. Okay? Because there's 2 different points in which it's at the same time. It's just a really weird question. So, vertical line test. Since we're talking about that, is this question a function? I draw a lovely vertical line. And yes, all of the students that are with us during the recording have said, no, it is not a function before I even started this. But if I drew this and drew, can I please drag that? No. Okay. I'm just going to drag it across to make it look cool, but I can't for you guys there. So as soon as it tests that point, you then realize that like here and there at the same time, so it will be not a function. Okay, so now we're going to plug in stuff for equations. The best part about these equations is you're just putting in numbers and then working them through. As long as you know your PEMDAS, you should be fine. So we're going to start with 3 parentheses -2 squared minus 9 -2 plus 14. And of course, this is probably copyrighted, but plug it in, plug it in. Everyone knows how this works out. -2 times -2 becomes a 4. So it'll be a 4, put a 3 there, minus 9 is 2. So I did my exponents. I don't have any parentheses. My next step is going to be my multiplication division, right? start with my multiplication from the right to from the left to the right. 3 times 4 is going to be 12 minus 9 times 2. The minus 2 is going to make a positive 18. There you go. So plus 18 plus 14. So at this point, I don't have any division left. I don't have any multiplication left. I'm going to go addition, subtraction. And we're going to speed up. What? 44. Well, someone already beat me to the gun. 2 and 8 makes it 10. 1, 2, 3, 4 plus 4. Yep, 44. Hey, a student actually beat me in getting to the end of that question. That should say something. So that means that when x equals negative 2, f of x equals 44. They won't want you to write it that way, but if you think about it this way, you can also look back at this and go, this is x, that's y. When x is negative 2, y will equal 40. They don't always mean the same things, but for variables, they may mean the same things. So it's useful to know that. Questions are getting faster, actually. Find the domain of the function without using builder notation. Write out using builder notation. So they're doing this by, okay, yeah. So the biggest thing that will affect a item with an x squared is either a square root being on it or a item with an x value on the bottom side of a division line, because at this point somehow the bottom could equal 0, and we don't want that because that'll equal, you know, bad. Things don't equal 0 underneath the division line, so it just becomes a null point on a space. So this one would look like a chart, and just at that one spot, it wouldn't exist. There's just a spot there that didn't happen. It's where it should be, but it can't happen there because of division of zeros. This one, on the other hand, basically turns the graph on its side this way, and then chops off the negative half because negatives can't happen in square roots. So this whole side just doesn't exist, and then you get that half turn graph that you've seen before. I'm going to draw that back because I want that back. So those are the only two instances in which there would be a problem with your functions. And this one would be a point issue, and this one would be a from here to there issue. Any other instance, it's all real numbers. So with set builder notation, all we got to say with this one is for the domain, the range with that double R equals all real numbers. Okay? It's another one of those definition things that the only reason why it's weird is because the two rules.
So if they give us an equation like that, they
Yeah.
say that f equals 2, for example,
Yeah.
how you say all real numbers?
If they say that f equals 2?
So for example, the number 11.
Yeah, hold on. So like the one we just did?
Yeah.
Question 13. We're going to find the domain of the function right out using set builder notation. Now this one we do have to work out because there is a square root function in here. Now as a square root function, we will just simply set this item, which is 9 minus 3x, will be set as greater than or equal to 0 because it has to be a positive side of it. And then from there, we can do this fun little fact where we square both sides. The squaring will cancel out the square root, and 0 squared is 0. So loopholes, 9 minus 3x greater than or equal to 0. And then we will move the 3x over that way or that way. I don't know. It's easier if we move the 3x in this scenario because it's negative. So what we'll do is we'll move the 3x over by adding 3x to both sides. And that'll cancel this out. And then we'll have 9 is greater than or equal to 3x. And then from there, we'll just divide both sides by 3. Cancel that out. And we'll get 3 is greater than or equal to x. So that means that basically from infinity all the way to 3. So, voila. And then it'll just like stop existing there at 3. Because that'll be like its U-turn. It may be like really tall up there or down there if there was something on the outside of the brackets, but there wasn't, so we don't have to worry about that. So at this point, we're just going to look at it and go, for set builder notation, we're still doing the domain, so we'll say D, and then we'll do our really pretty brackets. For all variables that are x, x must be less than or equal to 3. And come on. Pretty bracket on the end. Because we're just announcing for the variable of x. These are what those are. And that's just that builder notation answer for this one. Make sense? The math behind it makes sense? Get the little rules for it. Just literally set it greater than or equal to 0, and then solve for that equation.
So whenever we have,
Right. Like if there was a number on the outside out here, that would then change whether or not this was up here or down there. But that's a geometry thing, not a algebra. Well, I mean, kind of, but it's not something you should be worried about for your test. It's just a mathematical thing that's there, but the teachers aren't going to like scare you with it. Okay, so find the slopes and equations of A, B, and C on the graph. So this is going to be more of a call-out thing. There are 6 parts to this because there are 3 lines, and each one is requiring 2 things. So we're going to call them out pretty quickly. If we're looking at the slopes, the way we're going to know this is that if a slope is going horizontal, we know that its slope equals 0. If a slope is going vertical, m equals undefined, because it's basically infinity at that point, because it's going up infinitely as many as it wants for no movement left or right. And then we have one that is an actual equation that we can work with. As for the other part of this being the equation of the lines, if a line is either completely horizontal or completely vertical, it just equals the opposing value. So for example, C here is going up, down. That would be in the y-axis. So that means that the x value of it is equal to 4. So then just for C, it's just saying x equal 4, because no matter what y value is, C will always be, or x will always be 4. So the y, the m, and the b portion just all disappear. All right? It's usually a scary part. Okay. As for the a value, because it's going